So we came again with this new question, Stickler Thief. And Stickler Thief, the thief wants to loot money from houses arranged in a line. He cannot loot consecutive houses and aim to maximize this total loot and given an array, and array represents the amount of money in the ith house he can loot and determine a maximum amount he can loot. So we have a thief and he want to loot the array that are arranged in a line, and also it is mentioned that he cannot loot two consecutive houses. Like if he takes 6, he can't take 5. If he take 5, then he can't take next 5 or this 6. If he take this element 5, and then he won't take 5, he won't be able to take 5 and 7. And also his aim is to maximize the total loot. Okay, so how am I going to tackle this problem? So some of you might think that this is a greedy solution, just take 6, then 5, then 4. Okay, this will give us the average sum of 6, 5, 11, 11, 4, 15. And some of you think like, yeah, which one of is maximum, like the even indexed element, the sum of even index element, or sum of odd index element, which one is maximum? We will just take it. In this case, yeah, similar question, similar you can see like 3, 1, and yeah, here 5. Yeah, so you can think you can think in this way. Also, yeah, here you can see, yeah, some of you might think that this might work like we will just iterate through the array into even indexed event index sum is equal to 0 and odd index sum is equal to 0, and then we will just iterate through the array element, and we will store, we will add if I percentage, if I model 2 is equal to 0, then even I'm considering like 0 based indexing, that's why I'm adding the 0th element to this even index array, and else odd index sum plus is equal to array of I, and we will just simply return math.max of even index sum comma odd index sum. Yeah, some of you can think of this solution, but I will tell you why this is not correct. Yeah, it will run fine on some of the test cases, but it won't get submitted. I will tell you a test case in which it will fail. Here, yeah, you can see that our logic is not working very well. So this is a bad intuition, wrong solution. So why this is wrong? Let me discuss with you. Let's say you have element 1, 2, 3, 4, 5, 6. Okay, here you can see the 1, 3, 5, 5, 3, 8, 1, 9, and here you can see the odd index element are greater. Sum of odd index elements are greater than even index element. What if you take 1, 1, 1, 1, 1, 1, and you consider this one, and you choose like 1, 2, 4, 6, and you can definitely see that the odd index element are generally have greater sum than that even index element, but you can see in this case, like, we are just allowed to not choose consecutive element. We can choose any element, like we can choose 1, then we can skip this element, we can skip this element, we can take this one. So you can see that this is even index element, this is odd indexed element. So this is getting us the correct maximum sum. Like, yeah, you can see that in this case, let's say this is 5, this is 10. Okay, now you can see 5, 1, 6, 6, 1, 7. So even even indexed element will have a sum of 7, whereas odd indexed element will have a sum of 110, 110, 111. Okay, but you can make this much better. Like you can take this element, you can skip this element, you can skip this element, you can take this element. So this doesn't break any rule. Like you didn't choose any consecutive elements, so you can do like this. Means you can skip any elements to get the maximum sum. So this will give us a maximum sum of 5 plus 100 plus 10. So this will, the answer, actual answer will be 115. So this should be our answer, not this or this, like maximum out of those. So in this problem we cannot simply apply the greedy solution, so we have to try to take all the combination of index. Like we have to check whether we should take it, whether or not take it. So all those cases we have to think of. So all the cases, if we are thinking, then we should think of doing it with recursion. So yeah, since recursion check all the possible scenarios and find and give us the most like most optimized result. So we will just pass an array, we will just pass an index from which we are going to start, that is 0 index, and we will start with sum of 0. Means thief is empty handed right now. So enter rec and array enter I index through which we are iterating, and sum that the current amount of money that he has. So we will just simply return the amount of money, so we don't have to take this in our variable. So yeah, so here we will have a base case where this whole recursion will terminate, and all possible cases will be covered here, and we will just have a return answer. So in all the possible cases, if we are at that particular index, we have a choice that we can take it or not take it. If we are taking it, then we'll just add this array element to the thief's pocket and just move on. And we will not simply move on, because we will move to the 2 step ahead, because we can't choose the consecutive houses. That's why if thief is robbing that particular house, then he can't rob the consecutive or like his neighboring houses. That's why I'm moving this pointer to I plus 2, and in case of it haven't robbed that house, then nothing will be added to his pocket, then he can rob, he has the chance to rob that particular next index. Yeah, that's all the cases, because in this case we are, thief is starting from a point and moving to the other point, and he cannot move back, because in this case we are ensuring that till that index, till that house, he has robbed all the houses which will potentially give him the best result. So that's why there is no case to exclude the previous neighboring house. Okay, so we are moving from left house to right house and ensuring that the thief has chosen the best scenario previously, that will give him the best result or money, the total loot that he need. So we will just simply return max of take comma not take. Okay, and the possible base cases will be if I greater than or equal to array dot length. If it is arrow bound, then we will simply return 0. Yeah, and this should work fine for the small test cases, like who has lesser constraint. Also we have an error. So rec, so here is function name is rec, because yeah, my mistake, and we just have to return. I'm so sorry. Okay, so for recursion solution, yeah, it's working fine, but this will give us time limit time limit exceeded. Why? Because this is a pure recursive solution, and the time complexity of recursive solution is basically exponential. So we will have to optimize it. So we will create an TP array which will store the calculated results, till that house, we will be storing the best result in this TP array, so that in future if we encounter that same position at which the thief is standing, has stand previously in, like in his past experiences, he won't have to calculate again. So we will initialize with tp comma -1. We will pass this TP array. Yeah, once you find this recursive solution, then the memoized solution will be easy. Yeah, piece of cake. Okay, we will pass this TP array. We will store the calculated result. Okay, and we will check if it is already calculated. Means if it is not -1, then it somehow calculated, like, yeah. Okay, कैसे cast results will be directly written, means there is no computation involved while calculating it again and again. Yeah, that should work fine. Yes, I want to go with missing. Oh, there is some issue, like we want the number of houses. Okay, yeah, that's all. Yeah, it's working fine. Let's try to submit it. So the time complexity of this code is going to be of n only, because we are just going through each index, and even if there is a case that is need to be calculated, it is already stored in this DP array, because at each index we are storing in this DP array, so that we don't have to pre-compute, or we don't have to compute again and again. So this is the best part of this TP solution. Like we are just optimizing, we are just reducing our queries. Yeah, so there is one tabulation method which I will discuss in the next video. Thank you.